Good evening, my dear student. I am Rakesh Shabbe from Sunbeam Sun City. Jai Hindi, all my dear. My dear, today I am uploading the lens maker formula, thin lens formula, equivalent lenses, and all that. Now, here the topic is for the lens maker formula. I am beginning with the lens maker formula to do with the double convex lens or a convex lens, because double convex is also called a convex lens. Okay. Now, my dear, this formula can be derived by using a concave lens also, not only a convex lens. I will give at the end the diagram to derive the formula with the concave lens. It's my request that you, after looking the video for the convex lens, you all should derive the same formula with the concave lens also, because in the exam it can be by a convex or by concave can be mentioned. Okay, my dear, let's start with the topic. Why do we call this as a lens maker formula? My dear manufacturers, you all knowing that the different lenses are of different focal length. So now this focal length will be calculated by this formula. For example, my dear, if I have to make a lens of 15 centimeter of focal length, then I have to use this formula, my dear. So ultimately this formula is used to calculate the focal length of the lens. Let me tell you, this formula is used to calculate the focal length of the lens with the help of refractive index and radius of curvature. There is only the three things. We are determining the focal length by using the refractive index and radius of curvature. The two things we required, that is refractive index and radius of curvature, and hence this formula is to determine the focal length, my dear. Okay. And manufacturers are designing the different focal length of the lens with this particular formula, and hence this formula is called lens maker formula. Okay, now my dear, so ultimately this question is having a relationship between focal length, refractive index and radius of curvature. In the exam, CBSE exam, since we have an applicative question, so instead of asking the lens maker formula, the question can be this way also: derive the focal length or state the formula for focal length with the help of radius of curvature and refractive index. Okay, so please make a note of this, because another formula is thin lens formula, which I will do it afterward, where we require V, U and F. V, that is image distance, U, that is object distance, and F, which is focal length. But in this formula, my dear, you will determining the focal length of a lens by using radius of curvature, that is of a given lens, we have a radius of curvature, and by using the refractive index. Okay. Now, my dear, here I have used the double convex lens, but what we have done, I have drawn two figures in front of you. This is the first refracting surface of the convex lens. Here I am writing first refracting surface, and here I have make that this is the second refracting surface. Here I am writing this is second refracting surface. So you all know that in any lens there are two refracting surfaces. So let's start with the, my dear, the first refracting surface I am using, and I will get one equation. By using the second refracting surface, I will get another equation. I will combine both the surface. It means I will combine both the equation and I will get a lens, and that will give us a lens maker formula. So my dear, when I use the first refracting surface, that is the name of the surface is say APB. So here I am writing when refraction takes place from first surface, name of the surface is APB. My dear, in this case you can see when this refraction is taking place from this surface APB, the point object is kept in the rarer medium, and the refractive index of the rarer medium is mu1, and the image of this point object, that is I1, which is a real image because it is on the other side, we obtained in a denser medium. So normal we have to use the refracting surfaces formula for all this. We just have to write one or two lines and then immediately we have to write this equation. And rest all I have written, the image is obtained at V1, the radius of curvature is R1, and the distance, the object distance is minus U. All these things are written over here, you can see. So when refraction takes place from first surface APB, let a point object let a point object O is kept in rarer medium of refractive index mu1, its image is obtained. Its image, what is the name of the image, my dear? In the figure you can see its image I1 is obtained in denser medium. Its image I1, which is a real image, obtained in denser medium of refractive index mu2. Simple line. I have written very simple line, my dear. Everybody can understand this point, that a point object O is kept in rarer medium, yes, of refractive index mu1. Its image is obtained. Its image is nothing but I1, which is real image obtained in denser medium of refractive index mu2. Right? Hence, by using formula of refraction at single surface, by using the formula of refraction at single curved surface, we have, now my dear, you all can see the formula here. The image is obtained in a denser medium and the object is kept in the rarer medium. So what will be the formula? This will be mu2 divided by V minus mu1 divided by U is equal to mu2 minus mu1 divided by R. My dear, this is the formula, no doubt. This is the formula for which case? It is a formula for the case where image, here you can see my board. Here the image V is obtained in the denser medium, because here I have written mu2, and object is kept in the rarer medium. Here I have written mu1. Am I clear? You can see U is obtained in mu1 and V is obtained in mu2. Yes, the object is kept in mu1, that is U is in mu1, and the image is obtained in mu2, so mu2 will be with V. Am I clear? So that is, my dear, but here according to figure, this is the formula. But according to figure, but from figure, my dear, from figure, V is equal to V1. Earlier in formula, when we have done this formula, the formula was mu2 by V minus mu1 by U. But now, my dear, in figure, V is your V1. You can see the figure, you can see the diagram, and R is equal to R1. R is now R1, because I am taking first surface, the radius of curvature is taken as R1. So now what will be the formula? Therefore, this will be mu2 divided by V1 minus mu1 divided by U is equal to mu2 minus mu1 divided by R1. I hope it is clear, and this is the equation number 1. So I hope it is very simple. You can clearly see, and I have done all this in my earlier video and theories also. For this reason, I have done this theory very well. For refraction at a single curved surface, please go through with that. I have given you a logic that image is obtained in denser. You can see V in mu2, V in mu2, V in mu2. V is in mu2 and U is in mu1. So I have written mu2 by V minus, because V obtained in mu2 and U obtained in mu1. So formula will become mu2 by V minus mu1 by U is equal to so and so. That is mu2 minus mu1 by R. But my dear, here, since it is a first surface, we have taken image distance V as V1 and R is my radius of curvature, which is right now in the figure is R1. So I substituted, and the formula will become mu2 by V1 minus mu1 by U is equal to mu2 minus mu1 by R. Now my dear, let's go to the second refracting surface. Now when I go to the second refracting surface, that is, the name of the surface is APD. You can see the figure. The second refracting surface is APD in the figure. So now my dear, when the refraction takes place from the second surface APD, you all can see this image I1 which was real due to the first surface is now this image I1. You can see here I have produces it over here. You can see this line carefully my dear. Now this image I1 for this surface, for the second surface, that's a line which you are supposed to write. This image I1 for the second surface APD my dear act as the virtual object. You can see I have produced this line and you can see here this particular ray my dear. So this ray if you produce at the back, this will act as the virtual object, and you can see this line is in which medium? It is in denser medium. I mean to say that this image I1 which was for first diffraction surface is now the virtual object. And therefore I have drawn this as a dotted line, and here I have drawn the solid line to understand that it is refracted because it is in denser medium. It is normal. So of course sir, it is coming from denser to rarer. So the light will bend away from the normal. Here you can see the bending. It is a normal, and here the light is bending away from the normal, this one. And here I can make a name N. You can see. So my dear, here when refraction takes place from second surface APD, the image I1, because for this it was the image, so the image I1 acts as a virtual object. This act as a virtual object, and where this virtual object, you can see this line, it is very important for a figure. This act as the virtual object in the denser medium, of Ri mu2. So now the object for this case is in Ri of mu2. So here my dear, you can understand, you can logically place the formula. Now the object is in denser medium. And the image is obtained in the rarer medium, and it is bending away from the normal. You can see, because this is the normal line, because the object or the light is coming from denser to rarer, where here the light is bent towards the normal. You can see, because it is coming from rarer to denser. So here the image I1 act as virtual object in denser medium of refractive index mu2, whose real image I, this is a real image because object is denser in denser medium. No doubt it is a virtual object, and image obtained in rarer medium. So of course the image is a real image because it is on the other side. So whose real image I is obtained in rarer medium of Ri mu1. Clearly, I hope it is the simple topic. Sir, the image I1 for the second surface, the image I1 act as virtual object, and this object is in the denser medium of Ri mu2, whose real image is I, no doubt, which is obtained in the rarer medium of refractive index mu1. So according, therefore, by using formula, we have mu1 divided by V, because why mu1 my dear? Earlier it was mu2, because now the image is obtained in rarer. So it is mu1 divided by V, and object is U, which is capped in denser. So here it will be mu2, and this is equal to mu1 minus mu2 divided by, that is mu1, and here it is mu2 divided by R. This is the formula my dear. Actually this is the formula. I am using the formula. But my dear, you can see from figure, here U is equal to V1. You can see why U is V1. Sir, earlier the image is obtained at a distance of V1. the earlier पहले image कहाँ मिला था I1, this image is obtained at a distance of V1, and now this I1 which is the earlier as an image, now it become object. Now it become object for this case. So if it become object, so Chaube sir, the distance u is now the object distance u is now equal to the earlier image distance. And how much is earlier image distance? V1. I hope it is so simple. So you are understanding. See now sir, if what I1 act as the virtual object in this case, so no doubt if it is a virtual object, what was the distance of I1 earlier? Sir, it was V1. So now it become an object. So it become an object distance. So now V1 is the object distance, and V, that is image, is at V only. But my dear, R is equal to R2 because it is a second refracting surface. The radius of curvature is R2. So what will be the formula? Therefore, this is mu1 divided by V minus mu2 divided by V1 is equal to mu1 minus mu2 divided by R2. Mu1 divided by mu2, mu1 minus mu2 divided by R2. So this is the formula, my dear, when I will use the second refracting surface. So what is two very important concept? Sir, here the object distance is equal to V1. And why the object distance is V1? Because sir, earlier the image I1 which is at V1 distance, earlier the image I1 which is at a V1 distance is now become an object for this surface, and therefore the object distance of this case is become V1. And radius of curvature is R2. I obtained the formula or equation number 2 by the second refracting surface as mu1 divided by V minus mu2 divided by V1 is equal to mu1 minus mu2 divided by R2, and radius of curvature is R2 because it is second refracting surface. Okay, now my dear, to get the lens maker formula, that is to get the total formula, because this is one surface, single surface. Now I will combine. When I combine the surface, I will get a lens. I will get a convex lens. I will get a double convex lens type. Am I clear when I combine? So what I mean to say that when we add equation 1 and equation 2. So remember the order, we have to add the equation 1 and 2 to obtain the right or actual lens maker formula. So let's proceed for adding equation 1 and 2. I will take a pause to wipe it out board, and then I will show how will we add and what the answer we are getting. So now my dear, it is equation 1. You all know that I write just now I have written mu2 by V1 minus mu1 by U is equal to mu2 minus mu1 by R1. And equation 2 is mu1 by V minus mu2 by V1 is equal to mu1 minus mu2 divided by R2. Now my dear, I have order here on adding 1 and 2. So as soon as I'll add equation 1 and 2, you can see vertically I have written. So mu2 by V1 and here minus mu2 by V1 will cancel. And then my dear, since I am adding, so here it is in minus because mu1 by U is in minus, whereas mu1 by V is in plus. So here I will write the plus one first. So this will be mu1 by V minus mu1 by U. mu1 by V minus mu1 by U is equal to, let us take my dear mu2 minus mu1 common in this. So if mu2 minus mu1 is taken common, so here my dear, it is mu2 minus mu1 upon R1. So no doubt 1 upon R1 will be as it is, because it will be ultimately, this is the first answer it will giving, but here it is mu1 minus mu2. It is not mu2 minus mu1, and I have taken common mu2 minus mu1, my dear. So here it should be, so that it is mu1 minus mu2. So what should I do? Here it become minus, this is 1 upon R2. I hope it is clear, because as soon as this minus will multiply here, you can see here, this minus when multiply here, the minus and this minus of mu1 will become mu1 as plus, and mu2 will come in minus, you can see, and that is my equation number 2. So here R2 will be written as 1 by R2 but with a minus sign, because I have taken mu2 minus mu1 as common. So now my dear, here I will get, therefore this will be mu1 common. This is 1 upon V minus 1 upon U is equal to mu2 minus mu1 into this is 1 upon R1 minus 1 upon R2. I hope it is clear. Right, here I have taken mu1 common. So the next step, my dear, dividing throughout by mu1. So when I divide throughout by mu1, what answer I will get, my dear? I will get here, therefore this is 1 upon v minus 1 upon u, because mu1 से divide किया तो this will cancel, is equal to mu2 minus mu1 whole divided by mu1 into this is 1 upon R1 minus 1 upon R2. I hope you are getting me, because this is mu2 minus mu1 whole divided by mu1. Now here, my dear, if I go further, this can be written as therefore 1 upon v minus 1 upon u is equal to, I split this mu1, denominator splitting, this can be written as mu2 by mu1 minus mu1 by mu1, I have splitted the denominator, into this is 1 upon R1 minus 1 upon R2. Now this can be written as 1 upon v minus 1 upon u is equal to mu2 upon mu1 minus 1, because mu1 by mu1 is 1, and here it is 1 upon R1 minus 1 upon R2. Now my dear, if you remember, I told you that mu of 2 with respect to 1, mu of 2 with respect to 1 can be written as mu2 by mu1. I hope it is clear. Mu of 2 with respect to 1 can be written as mu2 by mu1. Or you can say, if here I can do another thing also, if mu1 is Ri of air medium, then it is 1, and mu2 is Ri of glass, let it is taken as mu. So this is also okay. See, if mu1 is Ri of air medium and mu2 is Ri of glass, so if it is air medium mu1, so it is 1, and if it is glass, it is mu. So what will be the answer? This will be 1 upon v minus 1 upon u is equal to, my dear, mu2 is as mu, mu2 is taken as mu, and mu1 is 1. So this will be, my dear, mu upon 1, no need of writing upon 1. So this is mu minus 1, and here it will be 1 upon R1 minus 1 upon R2. So simple. Now my dear, here is one condition. And what is the condition? Look at that. Please don't write here 1 upon v minus 1 upon u is f. Please. Many students are doing ki 1 upon v minus 1 upon u is f. 1 upon f. And they substitute this 1 upon v minus 1 upon u as 1 upon f, and they write 1 upon f becomes so and so. My dear, don't do this mistake. Let me tell you, 1 upon f still we have to derive. That is thin length formula. So please don't write, since many students write this, since 1 upon v minus 1 upon u is 1 upon f. No, this is wrong. This is wrong step, because from this formula we have derived this. It is not derived before this formula. So right now we don't know. Please make sure from my video class, this one, that please make sure that you right now you don't know 1 upon v minus 1 upon u is 1 upon f. After this formula, when you will go for thin length formula, then you will have this topic that 1 upon v minus 1 upon u is 1 upon f. So don't write this step. This is wrong step. So what is the step? How we come to f? How we come to f? Now my dear, here there is condition, let object is at infinity. So my dear, from class 10th you know, if object is at infinity, the image is formed at focus. You all know, when object is at infinity, the image is formed at focus. So let object is at infinity, then image obtained at principal image obtained at principal focus. Please make sure this. That object is at infinity. Therefore, what is the meaning of this? U is equal to infinity. At that time, my dear, the image V is obtained at focus. I hope it is clear. So when U is equal to infinity, V is equal to F. So if V is equal to F in the case, therefore my dear, this will be 1 upon F, because this is 1 upon F, because I have written when object is at infinity, then image obtained at principal focus. So when this is 1 upon F minus 1 upon infinity is equal to, this is mu minus 1 into 1 upon R1 minus 1 upon R2. You all know that, my dear. Now here it is the last step. Everybody aware that here you can go for, since therefore 1 upon infinity is 0, because reciprocal of infinity of course is 0. Therefore this will give me 1 upon F is equal to, this is 1 upon F is equal to mu minus 1 into 1 upon R1 minus 1 upon R2. And my dear, this particular formula which I have written here, that is 1 upon F is equal to mu minus 1 into 1 upon R1 minus R2 are called, here I am writing, are called lens maker formula. This is called lens maker formula. So I hope you all clear with the lens maker formula. So this is a topic on lens maker formula where we need to draw actually 3 diagrams. This is a single surface diagram. Now I will show you a combined diagram where I will end this topic. So that's all from my side, my dear, on the lens maker formula. I will show you the combined diagram for this topic over here only. But this is your lens maker formula, and the formula is 1 upon F is equal to mu minus 1 into 1 upon R1 minus 1 upon R2. Take care, my dear, don't substitute 1 upon V minus 1 upon U as F, as 1 upon F, because still it is not derived. After this formula, I will derive 1 upon V minus 1 upon U is equal to 1 upon F. That is called thin lens formula, which is after this topic. Now my dear, I am showing you the combined diagram, because earlier I have shown a single surface diagram, but in the exam, my dear, if you wish, please draw 3 diagrams. The first surface, second surface, or you can draw this only a diagram, the third one which I am drawing. Otherwise, if you wanted to derive the formula nicely without any hesitations or without any burden, so please draw one diagram so that you can easily understood what is the topic. So here is the combined diagram. Here, my dear, say the point object O going here, it refract here, you can see in the glass, and now from here this will, because this is the first surface, right? So it is go here. Think over, okay, this is due to the first surface. So this is the diffraction due to first surface. But my dear, this light is going at the back in the denser medium, and here is happening the second diffraction also. So you can draw the diagram like this. See now, think over like this. Suppose your first surface nahi tha, second surface is not there. So of course this ray is going like this because of the refraction, and as soon as the second surface came here, the another refraction takes place at this point. You can see, my dear. So here is the real image I, here is the image I1. Now it acts as the virtual object for this surface, right? Here is the object O. Here you can draw the normal also, because this is the center of curvature, you can see. So here is the two center of curvature. One is along this way, that is, here is the center of curvature I can draw. C1, and here is the another center of curvature. And here I can draw C2. So these are the two center of curvature, my dear, in the diagram, which you can see easily from the figure, that there are the two center of curvature. One is C1 and other is C2. Here you can draw this is the normal N, and here is the normal N. So earlier, my dear, the ray is bending towards the normal, and this is the another normal where the ray is bending away from the normal. So you can see the two center of curvature I have drawn in my diagram. One is this one, right, and another at this surface. So this is the diagram, my dear. Here is optical center. So distance from here to here is V. Distance from here to here is R1. Distance from here to here is V1. Whereas the distance from optical center, here I can draw like this. Distance from here to here is R2, and the distance from here to here is U. So this is the diagram, my dear. Whenever you draw the diagram for the combined diagram, you can say. So this is the combined diagram, my dear, for the double convex lens or lens maker formula. Am I clear? So it's upon you, it's all up to you, my dear. Either you can draw only this diagram and derive entire derivation, or if you wish to draw a single surface diagram and doing one equation, then also, my dear, you need a third common diagram which is showing an entire diagram, both the surface together. Now you must understood, sir, at this surface the normal is at N. At this surface, look my diagram, earlier diagram. At this surface the normal is N, and at this surface the normal is at N. And here, in first case, the light is bending towards the normal, and in the second case, because normal is this now for second surface, the light is bending, this is the light, this one, the light is bending away from the normal. So this is the combined diagram, my dear, for double convex lens. So this is a double convex or convex lens for lens maker formula. So I hope you all clear with this diagram. Let's go to the next topic, my dear. Similarly, I can show you the lens maker formula by the concave lens also. If you wish, you can draw the lens maker formula by the concave lens also. I will show you that also. My dear, here is the point object. This will go here, and as soon as it will be fall here at this surface, you can see as soon as it is falling on this surface, it will be bent here. I can draw little down. It will refract here, and from here it will refract here. So here, my dear, I will get a first image. This is I1, and here my dear you can see this one is giving me the second image. So the first image is bending of this light. You can see here the object going here, incident at this point. Here it bent, and the image is obtained here. Now as soon as it reached here, it bent further like this, and the image is obtained here. You can clearly see, my dear. So these are the two diagrams, my dear. This is for my dear a convex lens diagram, concave lens diagram, and here you can put this answer that from here, if I draw this as an optical center, so this is your V, this is your V1, and this is your V1, this is your V, and this is, my dear, your U. So this is the diagram for the lens maker diagram for concave lens, and this earlier is the lens maker diagram for convex lens. So this is the double concave or concave lens for lens maker formula. So and apart from this, the derivation is same. Only the diagram is different. Derivation is the same because again the object is kept in the rarer medium. Here you can see it is a rarer medium of refractive index mu1, and this is, my dear, denser medium of refractive index mu2. That is glass. And the refraction takes place from first rarer, then the image obtained in denser. This particular image I1 is obtained in denser medium. But now this image I1 for the second refracting surface, this image I1 acts as the virtual object, and it will form the image, further image, that is real image, as I2. Virtual image, that is I2. Am I clear? So here instead of write I2, I can write this as I. So this is the final diagram for a concave lens, my dear. So that's all here for the lens maker formula. Now let us go for a thin lens formula. How to draw the diagram and how to derive thin lens formula by using the lens maker formula.